Today's topic is analytic proof, or sometimes it's referred to as coordinate geometry proof. We're going to do this lesson for 2 days, so this is the first part, and you can use the date of May 11th. There are 5 pages to the note packet. We're going to complete the first 3 pages that you see here today. And then these are the 2 pages that you can find, but we'll need these for tomorrow. Analytic proof is the last type of proof that you're going to do in geometry. Sometimes they call it coordinate geometry proof. And basically what we're going to do is prove that we have triangles, rhombuses, parallel sides, things like that. And we're going to use algebraic principles to prove our situation. So there's a lot more math in this type of proof. So these are the formulas that we're going to typically use in coordinate geometry proof. So there's not a lot of variety. You just have to pick the method that you would like to use. So normally in an analytic proof, we're going to use the distance formula, the midpoint formula, and the slope formula. So just to review the distance formula, we have the difference in the y's squared, the difference in the x's squared, and that whole answer is square rooted. Remember, an exact answer is left in simplest radical form. We're going to use this formula to prove that we have sides or lengths that are congruent, and it also works if you're trying to prove that things are not congruent, because clearly we'll be able to make a comparison. The midpoint formula isn't used as much, but in this method we add the x's, divide by 2, add the y's, divide by 2. Remember, we use capital M, and this is just an average location. So you can show that distance between points is preserved, or that the location of the midpoint is preserved. But again, sometimes they just ask you to calculate the midpoint. They don't really ask you to prove anything with it. The third formula is the slope formula, change in y over change in x. And we're going to use the slope formula to prove that we have parallel or perpendicular lines. And same with distance. We could be proving that we don't have parallel lines. The process that we're going to use to go through each of these problems, I highly recommend, I want you to draw and label a graph. I'm going to attach graph paper to the assignment. Once you've drawn the picture, we're going to formulate an approach, but you're going to want to state the formula that you're going to use before each calculation. So in part 1, if you're going to use distance, we actually state the distance formula and then move forward with our calculation. We're going to show all work. Don't try to be skimpy about it. If you have to do the distance formula 4 times, I need to see that work and that substitution 4 times before you move on. When we get to the end of this proof or this section, we're going to write a conclusion statement. Make sure you support it with details. Pretend like you're in English. We want to give facts. We want to incorporate our math, and then finally state a conclusion. So usually it's 2 to 3 sentences. And then we're going to repeat the process if needed. So if that was just part A, we now need to move to part B. So again, we would state the formula we're going to use, show all of our work, and then write another conclusion. If you pick wisely, sometimes the work that you show in the first part can be used in the second part. So we want to think smarter here so we can work smarter. In our first proof, we're given quadrilateral ABCD. They provide 4 vertices, so I think at this point it's helpful to graph those 4 points. Please use your straight edge, and you can pause the video if you want to get this graphed and labeled before we move on. So there's the quadrilateral. We have to prove that it's a rhombus. Now I'm going to bring up some information. You don't necessarily have to write this down, but this is what you need to be thinking about when you're approached with these. Back in our quadrilateral unit, we said to go from a generic quadrilateral, we need to go to a parallelogram first. Working in the coordinate plane gives us 3 options to prove that it's a parallelogram. The first is to show opposite sides are parallel, and we would use slopes. We would have to show opposite sides are congruent. We could use distance formula. And for both of those, you're going to do two sets. So two sets of opposite sides. And for number 3, you could show that the same two sets of sides are both parallel and congruent. No matter which method you pick here, there's going to be 4 calculations. But the second step then is to prove the parallelogram is a rhombus. So you can pick which method you would like, but if I can save myself some time and energy, the method I pick in step 1 is hopefully usable in step 2. So we would have to prove either 4 congruent sides, and yes, you can do that, but it's an inefficient method. Or to prove a rhombus, you can show that 2 consecutive sides are congruent. That's the best, most efficient way. So if you're going to show you have congruent sides here, then it's probably best to show that opposite sides are congruent using distance for part 1. This way, all the math can be used in all steps. All right, I've got all my vertices labeled. So if I'm going to use distance, I start with the distance formula. So you state it generically, and then we're going to proceed to calculate the length of each side. So I'm going to start with side AB, and remember, if you want to work ahead, you can stop the video so I don't reveal any answers. Be careful when you sub in that you're only focusing on A and B, and I can see that the side length is 5. Side AD, subbing everything in, and I see that it also has a side length of 5. CD is the side opposite AB, so this would be my first set of opposite sides congruent, and sure enough, they're equal. And then the last side I need to calculate is BC. So BC and AD are across from each other, so that's your second set of opposite congruent sides. So at this point now, we're going to write a conclusion to show that we have a parallelogram. So we want to start with a fact. So we're going to say a parallelogram has 2 sets of opposite congruent sides. I'm saying that because I used the length of their sides. If you use slope, you would say a parallelogram has 2 sets of opposite parallel sides. So you want to tailor it to whatever math you're using. I'm supporting it with details. AB is equal to DC, which is equal to 5, so those opposite sides are equal. And BC and AD equal 5. They're equal, so therefore quadrilateral ABCD is a parallelogram. Now I have to further prove that it's a rhombus. So I'm just going to add another statement now. I don't have to do any more calculations. But I'm going to start with a fact. A rhombus is a parallelogram with 2 consecutive congruent sides. We'll support it with our math. I chose AB and BC equaling 5, those 2 consecutive sides, but you can select any 2 consecutive sides. And therefore, parallelogram ABCD is a rhombus. So this is our first geometric proof. In example number 2, we're provided triangle PQR with its vertices. So I'm going to go ahead and graph that. There are 2 parts to this proof. We have to prove that the triangle is isosceles, and then we have to further prove that it is a right triangle. So I've got my vertices labeled. I'm going to highlight part A. We're going to first prove that it's isosceles. You can look at the diagram, and this is why drawing the picture is helpful. To me, when I look at that, it looks like PQ and QR are my equal sides. I could be wrong. Looks can be deceiving, but I'm going to start there with my distance formula to show that the sides are equal. So remember, we start with a formula. We're going to calculate the length of PQ. And again, I have a distance of 5. I believe QR is the same length, so now I'm going to go ahead and calculate QR. And again, I have a length of 5. If this did not come out to be 5, I would proceed and do the third distance on side PR to see if I can get another side congruent. But since I've met the criteria, I'm going to go ahead and write a conclusion at this point. I'm going to start with the fact that an isosceles triangle has at least 2 congruent sides. I'm going to say that PQ equals QR and they equal 5. So therefore, triangle PQR is isosceles. We do have a part B at this point. So we're going to focus there, now proving it's a right triangle. Distances won't help, so the math we did in part A won't help us in part B. We want to prove that we have a right angle, And the way to prove a right angle is to show that I have perpendicular lines. That can be done through the slope method. So we're going to state our slope formula. I believe that the right angle is at Q. So I'm going to calculate the slope of side PQ. And you do have to show the work even though you've graphed it. We don't want to just count, rise, and run. We want to be accurate. So change in Y over change in X give me a slope at PQ of 4/3. Now I'm going to calculate the slope of QR. So again, I'm subbing in, and my result is -3/4. This is good. Remember from past lessons, when lines are perpendicular, their slope should be negative reciprocals, and they should have a product of -1, and that's what I'm seeing here. So I'm going to go ahead and write my conclusion. I said a right triangle contains one right angle, and the angle is formed by perpendicular lines. So you're stating what you know. State your facts. I said slope of PQ and slope of QR have a product of -1. You can also say that they are negative reciprocals. Please don't use the word opposite reciprocals. That's not a thing. But that proves that they are perpendicular. Therefore, triangle PQR has a right angle and is a right triangle. So it's fairly straightforward. Sometimes the math gets a little tedious. This is homework number 126. It will say day 1, coordinate geometry, analytic proofs. There's only 3 problems on here. I'm going to recommend that you do this one digitally, or if you have your own graph paper, do it on graph paper. You can draw the picture and then do the math right on that graph paper. And then if you have any questions as you're going through this, please make sure you contact me. Remember, I'm taking spot checks on daily homework, and that adds up to a quiz grade at the end of the week. So you want to ask your questions and you don't want to leave things blank because it just hurts you in the end. Have a great day.